Welcome to the SolidCAM UK Technology Centre and welcome to our latest event. Today we have a selection of partners for you with machine tools, cutting tools, work holding, measuring, simulation, testing, and together we'll be demonstrating how we can collectively show you a total solution for manufacturing and machining. So throughout the event we'll be using SolidCAM software, showing the various strategies and including our powerful iMachining for fast metal removal. And before I hand you over to Ian and Ben, who will go through the live cutting session, I just want to remind people that we are cutting things live today, so we'd encourage you to ask questions throughout the session and hear the answers that you all want to hear about and things like that. So enjoy the day, don't forget to ask questions, and we'll see you at the next event. Thanks.
Thank you, Gordon. Welcome to the SolidCAM UK Technology Centre again. This is our 5-axis seminar part 2, where we're going to be showing a little bit more on iMachining in a different vein. We're going to try and show this one, hopefully more than try and show this, but we're going to show this cutting around a 4th axis as well. So just a little twist on what we've been doing in the last few seminars. You can hear we started the machine already, so that's ready for us. We'll have a look at that in just a minute. But first of all, just a big thank you for all our partners for helping us out and doing these presentations. So today we got tooling supplied by Quick Grind. The machine's obviously the ROMI, it's a DCM 625 axis machine, which we'll be using, and you'll see that throughout the seminar today. All the work holding has been supplied by Shunk. The tool holding is supplied by Nikon, and obviously we're also showing some verification later of the toolpath on there, and that's in conjunction with CG Tech with VeriCut. So a big thank you to all these suppliers for helping these out and making these events. It's a good showcase, so we can show off everybody's products on there. We'll be hearing from each individual partner throughout the seminar on there, so we'll get individual information. If you want to get any information or you want to get any questions please do so. The options are available to you to do that through the GoToWebinar software which you're using, or through Facebook if you're watching through there. So first of all on here, this is our UK Technology Centre, as you can see on here. We've got the machines on here, we've got the mill turn up in the corner, there's the 5-axis here, and the D1000 3-axis machine here. And the reason for having all of this is so that we can prove out, both for customers and for prospects, and if we bring out new software we want to play around with it to make sure everything works so we understand how it all works. We've got these facilities. So again, if you're a prospect or a customer and you've got something you want to challenge us with, we've got the facilities. We can take it up here. We can not only show you the software doing it, but we can obviously show it to you on the machine as well, just to show that what we're actually saying in our advertising, in our promotions on there, we can actually do as well. So that's one of the main reasons for it. This is also the main UK headquarters for SolidCAM UK. So not just the technology centre on here, we've got all the offices on here, so we've got all the sales and admin up here. We've also got a full support centre up here as well. So this will cover any customer support, whether it's email, phone, internet, whatever we want to do on there. And again, they have access to the machine, so if they need to check anything, we have that facility. We also have full post-processing support here as well. Every post-processor provided in the UK for any machine is developed here. We don't need to go elsewhere for that. We are completely self-sufficient from this point of view. So again, any support which is needed, anything on downline, it's all done locally in the UK. So what you're going to see today, as we've said already, is we're going to see a bit of iMachining on there, which is actually running at the moment. We'll go into that in a little bit more detail, and again, ask any more questions you want. We're then going to finish the flanks of this part on here with some barrel cutting on there, but also we're going to do a little bit more on here as well, just to show a few other little bits and pieces which sometimes gets neglected in presentations. We'll fully deburr the part. We'll engrave on there. We'll do some 5-axis drilling around the part as well. We haven't got coolant in the machine, so we're only just pipping the part, but you'll see all of that going on as well. So you'll see exactly what we're doing as we go through the afternoon. Just about to pass over to Ben Miller, our applications manager. We've got along the front of the desk here, we can see some of the parts which we've cut in various seminars. So these are all on display throughout the technology centre, so anybody coming in will see exactly what we're about. So I'm going to pass over to Ben now, and we can carry on with the afternoon.
Thanks, Mark. So yeah, like you say, the machine's running at the moment. So we'll have a look at the rotary iMachining. So you can see this is the 12mm bull nose from Quick Grind. So it's 2mm radius on the bottom. We're running at 165 meters a minute at 0.06 chip thickness. So the step over roughly equates to, the maximum step over is about 0.7 with a depth of cut of 22 millimeters. You can see the C-axis rotating around there. So instead of us doing a normal XY pattern or XYZ roughing, we're using that rotary axis and going around the job there to create these blades as such on the component. You can see the component on the desk there in the middle. I'm going to show you the component now in SolidCAM. I'm going to show you how we've programmed this and how we've programmed the iMachining around this component, and then when we come back we'll be able to see some more live cutting.
So we're first going to have a look at a presentation of SolidCAM. We're going to have a look at the features and benefits of SolidCAM, and we're also going to have a demonstration inside the software as well of the part that's been programmed for today's seminar, how it's been programmed, and then we will cut back to the cameras in the machine to have a look at this being cut live. So SolidCAM are leaders in integrated CAM. The major benefits of using SolidCAM inside SolidWorks are that we have the same look and feel through a seamless single window integration. There is full associativity inside SolidWorks as well, so any model changes that are made will automatically update the toolpaths in SolidCAM. SolidCAM is working inside the SolidWorks assembly mode to define fixtures, tooling and vices, and we've also been gold partners with SolidWorks for the last 17 years. We have a complete integrated solution inside SolidWorks. We are a modular system, so we can add the specific modules needed and when needed as well, so you don't have to have all the modules all at once. If you buy a new machine and need extra modules, these can be plugged in afterwards. Moving on to our iMachining module. So this is our high-speed roughing operation inside SolidCAM with a technology wizard built in as well. So we get increased productivity due to shorter cycle times, up to 70% and more cycle time saving. We dramatically increase the tool life and unmatched hard material machining as well. We see outstanding performance when using small tools, and we can use iMachining on 4-axis machines, 5-axis machines, mill-turn machines as well. High programming productivity and a very short learning curve. The unique wizard will optimize the feeds and speeds for you, including the depth of cut based on the stock and the tool material, as well as the machine specifications. So this takes the headache out of programming these high-speed roughing operations. So iMachining comes in 2 stages, all built into the same operation. The first stage of iMachining is to create an intelligent toolpath, so an efficient tangential toolpath which will ensure constant tool load on the machine. And then the second part of iMachining is the technology wizard. This will calculate the cutting conditions for any given machining operation. So this will calculate things like the speed, the feed, the depth of cut, and also the cutting angles. So we can have variable cutting angles. You can see there from 80 degrees to 10 degrees we can have set the maximum and minimum cutting angles based on what we wish to achieve, or we can let the wizard handle those maximum and minimum based on the material parameters that it's been given. You can see there on the left hand side at 20-degree engagement the feed rate is a lot higher than it is on the right hand side at 50-degree engagement. So iMachining will fluctuate the feed rate based on its engagement and its contact points as well. Also, the patented unique features inside iMachining are we have the morphing spirals only in iMachining, as you can see there on the left, so with a varying width of cut. And on the right hand side we have intelligent separation as well for iMachining, so we can separate areas with channels to maximize the spiral area. You can see there on the left hand side we're machining up to a wall. Now once we're machining up against the wall we're going to be full engagement with the cutter. So what iMachining does is it separates this section out and machines in a sort of lace strategy here against the wall, and creates these two channels here to leave 3 final areas for spiraling. So you can see on this next slide here we now have the 3 morphing spiral areas that are being machined by iMachining. This is more efficient and better for the tool. So optimal speeds and feeds for iMachining. So the technology wizard will calculate these speeds and feeds for you based on data that we have initially entered. So we would initial the material properties. We obviously select the geometry that we want to machine. We have the tool geometries and we put in the machine parameters. This will then calculate all of these that we see in red here. So the technology wizard will calculate the depth, the feed rate, the step over and the spindle speed, all synchronized together. Now the depth of cut is calculated inside iMachining, and it is calculated on an optimal depth of cut to reduce vibration. We're looking for an ACP close to a whole number. Now if you look on the left hand side here, ACP1, that is 1 full engagement with the tool. This is minimal vibration. If we look on the right hand side here, we have many contact points and we have an ACP of 4.5 as we hit the top, so we have a gap. Now this will produce vibration based on the fact that the tool has load and there is a flex point at the top here. With this one here we're in full contact on the left hand side here. Now the cutting forces are only now in one direction, to the left. On here an ACP of 3 would be fine as well, so we're looking for an ACP closest to a whole number as we can, and again iMachining will calculate this for us. iMachining is a patented technology. No other system can use our technology. You may see other systems using the spiral or morphing toolpaths, but you won't see any system using a spiral toolpath and also calculating the speeds and feeds and depths of cut using our technology. So let's have a look at a demonstration of the component that we're actually cutting live on the machine today. As you can see, this is the component. If we just have a quick look at the setup, we've got it held in the shunt chuck there, and we're using this on the Romy DCM 5-axis simultaneous machine. So we're going to have a look at the iMachining that we've just spoken about and how we've actually applied this toolpath to this job. So if we have a look at the geometry that has been selected, you can see there I've selected the wrapped line around there, and the yellow marking at the top shows that that is an open edge. The tool we're using is the 12 diameter bullnose from Quick Grind. So you can see it's 12 diameter, 2mm rads. It's actually a 5 fluted end mill as well. and we've given it the iMachining data, so here's 36-degree helix angle, and it's a premium carbide, and we're also using EN24T as our material. Now the holder is the Nikon holder. Nikon also supplied the solid models, so I've been able to import those straight into SolidCAM so that we can do full collision detection with all our toolpaths. If we have a look at the levels, the upper level is the outer diameter and the pocket depth is down to the inner diameter of this component. The software is telling us we're nice and green, 22.2mm step down, and the speeds and feeds you can see there at the bottom. If I change the machining level, you can see that the speeds, feeds and max step over all adjust relative to each other. And if we have a look at view 2, we can see we're running 165 meters a minute with a 0.057 chip thickness. So if we have a look at this toolpath, you can see we've got that nice morphing toolpath all the way down that slot, and it's actually wrapped around the Z, so this is going to do this in rotary mode, so basically with the C-axis of the machine. So if we have a look at that now, you can see the simulation of that happening. So we've got the live cut in there at the top left as well, actually on the machine. You can see that it's wrapped around that C-axis. It's got a nice smooth toolpath. And you can see that in the full machine simulation there as well inside SolidCAM. So a little bit different to the norm today. We're not just doing iMachining as a 2D or a 3D toolpath. We're actually doing it wrapped around that rotary axis and get that nice smooth toolpath. You can see the chips coming off nicely there. They've been thrown away from the material as well, so they're not going to get trapped inside the inside that slot or anything like that. So that's one slot on there. We want to do the other 3 slots as well. We don't have to apply another toolpath. We can simply do a rotate, so 90 degrees, 3 steps, include the original, and insert the 3 steps there at 90 degrees apart. Click OK and click Save. You can see that creates that extra toolpath in each slot.
Welcome back. So you can see the machine's still running. It's on the barrel tool at the moment, but we've had a few questions regarding iMachining while we've been running that presentation, so go over a few of those at the moment. So yeah, one of the questions, can 3D iMachining also be used for prismatic parts as well as 3D work?
Definitely. I mean, there's various options within the iMachining package, but the 3D iMachining has a separate option for prismatic parts. So the main advantages from there will, if you're doing maybe work like electrical boxes, things like that, where you've got a lot of material to remove, lots of different levels within that pocket in there, it's just literally say, okay, machine that. iMachining will find all the different levels, apply all the right strategies to the right areas, and machine it as if it was if you like, a true 3D part. It will work the same way. It will take the deepest cuts first to maximise the tool engagement on there, and then step up to remove all the flatlands on that. So where the advantage is for iMachining on there is it's pretty much one click and that part is completely roughed. We'd only have to go back in, small finishing part is over there and your part's basically ready, it's all done.
Yeah, so as well, you've seen the component being using iMachining in rotary. So one of the questions that came in there as well, is there any difference in cycle time or performance when we're running iMachining simultaneously with the rotary axes?
Again, it's still using the same technology as it was if it didn't have a rotary axis on there. So if you like, all our speeds and feeds, steps and cuts and everything else are still being calculated and given to us by the wizard within inside iMachining on there. The one slight consideration which we just do take into consideration on there, depending on the depth of cut, we're working on a root diameter on there, so the depth of cut will be slightly greater at the top. So maybe we'll just ease it back on the wizard, we ease the machining level back maybe one slot to compensate on there if we needed to. But in terms of the way it's working, it's exactly the same. Speeds and feeds are all being calculated, they're being interpreted by the machine to get the correct rotary speed and feed on there. So again, chip thickness, everything else is being maintained exactly the same way.
Yeah, and with the obviously the rigidity of the part as well, we didn't, in this case, we didn't need to slide it back. We kept it at the full 8 on the machining wizard, and it run quite nicely, as you've seen. How complicated is the training for iMachining as well? That's one of the questions come in there.
Well, really, again, the iMachining in terms of a product for machining is still kept very, very simple. The same as all modules with inside SolidCAM, everything's set out in a very easy to understand manner. So everything's laid out, all the dialog boxes are laid out exactly the same way. So in terms of geometry selection, tool selection, everything else on there, it's the same way as doing your simplest of tasks inside SolidCAM. The only real difference on there is you've now got another page on there which is allowing us to monitor and to control the step overs, feeds and speeds. So you can add materials to it. You can use materials as defined in, say, the SolidWorks material library in there. You can suck that information straight across into iMachining. You can use the database, which is a very comprehensive database which is shipped with SolidCAM, and you can add your own materials. And really the only bit of information you need to add is the ultimate tensile strength of the material. Now, some of the materials on there you might need to adjust afterwards, but by putting in the ultimate tensile strength, you're going to get very, very close from day one. And the only thing you may have to put in, if you're learning from that material, is a machinability factor on there, so that if you come to use that material again in your setup, it will make those adjustments for you automatically. So in terms of training, everything else on there, it is very, very straightforward. And again, if it's here, if you come on site here, we can, and we have the ability to actually prove that on the machines for you as well. So you can not only just see it on the screen, you can actually see it live on the machine.
Yeah, as you say, the training facility is actually here as well, so it's a little office that you can't see. At the back there we've got a little training room, so the training facility being here, we can jump onto the machines during those training sessions as well and show you things working, show you iMachining and what we're doing. Now the tooling today has been supplied by Quick Grind. I caught up with Graham earlier on in the week, just had a little chat, so we'll go through that and he'll tell you all about Quick Grind and what they have to offer.
Afternoon, Graham, and welcome to SolidCAM Live. Thanks for being a part of the event today. Do you want to tell us a little bit about Quick Grind and what you do?
Yes, and first of all, good afternoon, Ben, and thanks very much for the invitation to your live event. We do work as a good partnership, and long may it continue. Quick Grind is a company, you know, we're a family-run business, been on the go for some 54, 55 years now. You know, and it's still independently run, based in Tewkesbury. We've grown exponentially over the years, and we're now employing over 30 people. We've got 30 plus multi-axis CNC grinders. Company products that we manufacture, we like to think, are up there against the best that's in the world. And it's a very good company to work for. Yeah.
Yeah, very good. So what a Quick Grind bring into today's event? What is it that you've supplied us today?
Was the main thing that we're looking at, you know, and in a selfish point of view, you know, we have got end mills that are involved in it and different geometries of cutter, but we're pushing very, very heavily on the barrel cutting tools. Yourself, you know, as SolidCAM, you know, you're very good at putting us on the spot and testing us for the different radius, the barrel cutters, and basically we can supply any radius. Today, the event that's the trial that's on today, the demo, is an 80 millimeter radius, but more and more we find it, especially driven by the power of the software, like a SolidCAM, you know, tailored to the part, you know, the radius of the cutter. Quick Grind as a company, you know, we can produce quickly. That's where our name comes from. We can produce any radius, any ball on the end, any flute, to suit whatever material, whatever geometry. And as we'll see today, as the demo's going on, the barrel tooling plays a major part in us moving forward. We've had recent breakthroughs with volume machining barrel tooling, because it's been a slow process, to be perfectly honest with you, getting the barrel tooling out there, because people basically just don't believe it, how much time saving there is, and the versatility that you can work into it. This coupling with the advancement of a 5-axis machine tool and the software getting better and better all the time. The figures that you see out there, 90% saving and stuff like that, it's true. It's not a gimmick, it's absolutely true. And companies are now buying into it, and they're buying not just one or two cutters to try it on a surface of that. They're putting it onto a lot of component parts, and they're buying volume now, like a standard end mill. So it's now beginning to, you know, crack through. It's taken a good few years. We've stuck with it as a company. Some folk have said to us, you're never going to get anywhere with it, but we have, and we're beginning to reap the benefits of it now. And likewise, not just the barrel tool and the rest of the cutters that we're using today, we can customise any tool to suit any application. As you probably know yourself, you ask us for different sort of sizes now, because you can aim it right at the part and get the right cutter for the right application. And so that's mainly what we bring to the table today. The part is a really nice part, and it's got some really nice sexy movements in it for a 5-axis simultaneous movements. So it's going to work out very nicely between us now.
Yeah, like you said, the versatility of being able to turn around those barrel cutters with any radius quite quickly, especially for us as well, doing demonstrations. We just obviously design a part, and then we fit the barrel cutter in there. So you being able to provide that's a real good sort of thing for us. I mean, a Quick Grind still open? I know we've had some tough times and things. Are you guys still open, still operating at full capacity?
We've never, as far as production-wise goes, we've never closed. You know, the guys in the shop floor, a lot of them deserve a bravery medal. You know, they worked right through the lockdown. We were producing parts, we had cutters through the night for some companies, doing the ventilator stuff and that. You know, we were sending it 2 o'clock, 3 o'clock in the morning and that. So take my hat off to the guys. We've kept working. And the doors are open for if people want to visit. You know, we're getting people in. It's by invitation only, but the technical centre, which you've used the facility yourself recently, is open. So if anybody else out there wants to use a technical centre, wants to use our meeting rooms, we're more than happy to speak to you. Come in, and we can talk over stuff there. So the doors are open at Quick Grind. We're in full production. You know, we always want more. So it's working very well. We're turning over at the moment, you know, on a standard delivery 2 to 3 weeks, but for a premium delivery we can turn stuff around in a week, which is fantastic. It's especially at this present time, because an awful lot of work at the moment's needing done quickly, because it's coming through and getting and hitting the machine shops out there in the big wide world, and then to react so we can react with them. So yeah, we're open. Yeah,
that's good. It's good to hear. It's good to hear. Well, thanks very much for your support today from you and everybody at Quick Grind, obviously, and we look forward to doing some more of these demonstrations with yourselves.
Yeah. Well, once again, thanks very much for inviting us, Ben. We do like working with SolidCAM, and we look forward to working again with you in the future. Thank you very much.
Thanks very much.
Yeah, Thanks for that, Graham. So, like I say, we do appreciate all the support we get from you guys and all the partners, really. As you can see, this is the barrel cutter running now that's been supplied by Quick Grind. This has got a 70mm radius on the barrel mill. You can see it going round those blades there to finish them. So this is running at a spindle speed of 5,500 revs at 1,200mm a minute, with a step over or depth of cut, whichever way you want to call it, is a 1.5mm. So again, compared to traditional ball nose that you'd be using, the step over is a lot greater, and we're running at similar speeds and feeds. So the time savings are a lot greater there. We've had a question as well: is SolidCAM only available as an add-in for SolidWorks?
Okay, the simple answer to that is no. You can also, I say, depending on your flavour of CAD, if you're an existing SolidWorks customer, there's an obvious choice to plug straight into what you've got. If you've got Inventor, then we also plug straight into that with Inventor CAM. It's exactly the same product, just obviously different interface. But we also provide SolidCAM as a standalone product, so it comes with its own embedded CAD, which effectively is a SolidWorks package, but bundled together by ourselves on here. So yes, we can do that. But also the iMachining is also available as a plug-in to NX as well. So if your preferred system is NX, but you want to get all the advantages of iMachining, then that's a possibility for you as well.
Yeah, and another question as well is there, if you've got a group of similar parts or components to machine, how complicated or how easy is it to copy an existing SolidCAM project and just replace the part for the new part?
Very straightforward. If they are very similar on there, then you've got an option inside SolidCAM where you can effectively open up your existing part, change the model reference to a new part, and reassociate all the toolpaths just with the synchronize. So obviously for best results on something like that, if it was a native CAD file, say a SolidWorks file or an Inventor file on there, then, and you're just updating sizes, things like that, it will pretty much do everything straight away. You just click a button, it will update everything, and you're away with your new sizes on there. Even if it's an imported file, say a step file or an IGES file coming in through there, it will do its utmost to try and reattach everything it can. If it can't, it will just come up with a little cross on there basically saying, look, just reattach me. So it's very, very straightforward from that point of view. So yeah, families and parts and things like that, very, very easy.
Yeah, nice and easy just to reselect faces if it does actually lose the face due to it being a different model. Now the machine we're using here is the Romy DCM 620. Now just to before we hand over to Eduardo, who's going to talk a little bit more about Romy and the machines they do. Just to elaborate on this, due to doing these events as well, Romy have actually sold this 5-axis machine to a customer, so this will be coming out of our shop soon. So it's good news for them. It's how these events work, and it's good advertising as well. So I'll let Eduardo tell you a bit more about Romy themselves.
Hi everyone. First, I'd like to congratulate SolidCAM for this event. Our company is happy to be part of it, among other very good companies that are also participating here today. So thanks for the invitation. Well, talking about Romy, we are a 90 years old company that for decades we have been manufacturing and selling machine tools, injection molding machines, and machine casting around the world. We are proud to be one of the few OEM in the world to take care of the entire manufacturing process of the products we sell, including the casting, the machining, the wiring, the sheet metal, assembling, etc. Which means that we have everything in our hands, not having to rely on some Asian suppliers, for example, so we can guarantee a lifetime support for our customers. I used to say that one of the main attributes of our machine tools, our CNC lathes, VMCs, HMCs, VTLs, and so on, is the robustness. Considering we have our own foundry as another business, we know about casting and both engineering, our foundry and our machine tools engineering, they have all the synergy to make the optimal machine structure. For our customers, it represents high rates of swarf removal and a stable and reliable machine, which means shorter cycle time, less scrap, and in the end, more competitiveness. Well, today, as we can see at SolidCAM, we have 3 machines. So the first one is the ROM GL240M. This is a turning century with CX and driven tools. It has 175mm chuck with tool setter, part catcher, bar feeder preparation. And this machine usually we sell for medium and high production for parts up to 260 mil diameter by 400 millimeters long. But still, you'll see it's a very compact footprint. The second machine is the D1000. This is a 3X VMC with 10K spindle, 30 tools capacity, high pressure coolant pump through the spindle. This machine offers all the flexibility of the VMCs, but with all the robustness of ROM machine. It still has a Siemens 820D CNC, which comes with the conversational programming shop mill, making the setup and more programming simpler and faster. The third machine, the last one we see here today, is a 5-axis with 15K spindle. This is really a full 5-axis machine, and it's a good fit for simple parts with more than one side to be machined, but also for very complex parts that require these 5 simultaneous axis interpolation. Well, if you have any question about one of these 3 machines or any other machine from our portfolio, please do not hesitate to contact our team here in our headquarters in Rugby. I hope you all enjoy the seminar today and the live demos. Thank you again, and everybody stay safe.
Thanks, Eduardo. If anybody needs to speak to any of the partners that are involved in today's event as well, please do contact us and we can put you in touch with them as well. We've had a question through while that's been running as well. Looking at the barrel cutter, it looks like a multi-function cutter, i.e. barrel and ball nose. That's correct. The barrel cutter's got a 2.5mm radius on the bottom of it, so it is effectively a 5mm ball nose as well on the bottom. So as you can see at the moment, running on there, it's cutting a floor. So we're running this like a ball nose. It's running at 1,000 millimeters a minute and a 0.5 step over, just to clear that floor off. Give us a semi nice finish on there. Another question as well, can you freeform draw any cutter geometry in SolidCAM? I'll let you answer that one, Mark.
Yeah, it's not a problem. In terms of milling tools on there, if you have a shape tool or have any form of tool which you want to draw as well, absolutely fine. You've got the option in there to create what we call shape tools inside SolidCAM. For milling tools, they're literally just a 3D or a sketch which is swept around. It's as simple as that. So you literally just draw your profile on there and that becomes your tool on that, and then you can use that for all verification and for simulations as well. So you can see the actual tool against the material to generating the shape which you want to generate.
Yeah, and in terms of the barrel cutter as well, we've got full support for various types of barrel cutters. They're just parametrically created through the tool library, so we don't need to actually draw the shape of this and spin it around. We can actually generate it by inputting the parameters in SolidCAM. So we do the oval form, we've got the lens tool, we've got the barrel shape, and we've got taper barrel as well. Yeah, I did remember all those then, Mark.
I was just about the prompt, yeah.
So we got another question as well. Is it possible to import the form tool in the form of an STL file?
Currently, you can import holders or any other part of it. The actual main tool on there, I mean, there are workarounds for it. In 2021, you'll be able to do all of that as well. 2021 is due for release in very early in January in the new year. So all of that support is all there for that then as well.
Yeah, so the holders that we're using as well, or the chucks, these have been supplied by Nikon. So a couple of different types of chuck on here. Gary Williamson's going to tell us all about those and about some of the other products that Nikon offer as well. So we'll pass over to Gary now.
Afternoon, Gary, and thanks for joining us for SolidCAM Live. Do you want to tell us a little bit about Nikon and the products that you offer?
Good afternoon, Ben. Thank you for that. Yeah, we're looking forward to this event, working with SolidCAM Live. I think Nikon, as people know, is synonymous with high quality, high performance engineering solutions within our portfolio. We've got the tool holder solutions, but also 4/5 axis rotor tables, presetters with tool management, angle heads, boring solutions, and our own facility on the advanced manufacturing park with our own range of machines.
Yeah, very good. And what is it that you're bringing to the event today? What is it that we're seeing in the machine that's been supplied by yourselves?
Yeah, obviously you're doing a 5-axis simultaneous application. Very nice machine part there. And you're looking at fast metal removal rates with some access restrictions there. Within our portfolio, we've got quite a number of solutions for that, but the one that we're promoting and presenting today is the Mini Chuck Advanced Alpha system. It's a tool holder with a very small nose diameter. There's no nuts, as you'll see on the Mini Chuck Advance. It's a high gripping force chuck with gripping right at the nose to ensure maximum gripping. So, around 3 times the gripping force of a typical hydraulic or shrink system. So if you're looking for fast metal removal rates, then that's a great tool. It's high speed balance as standard, 30,000 RPM. And with coolant options either centered through or a jetter coolant system. It operates on a bevel gear system, so that the collet itself has got a screw portion in the back of the collet, which engages in the holder and is drawn back. So hence the reason why we don't need a nut. So really small nose diameters there on a 4 millimeter capacity. You're down to 15 millimeter nose. 8 is 20, and up to 12 capacity is a 30 nose diameter. So yes, a great solution for high speed, fast metal removal with restrictions of access. But importantly, it's an accurate chuck as well, within 3 microns of accuracy. Very important to obviously the cutting tool life and the surface finish for the final component.
Yeah, I must say it's been great to use the chucks. To be honest, they're very easy to use, and the change of the tools is so quick in them as well. I mean, obviously we're in these strange times at the moment as well. Are you guys still open? You got your tech centre that you mentioned there in Sheffield as well. So are you still operating as normal?
Yeah, absolutely. Yeah, obviously there's current restrictions in place, but the doors are open. We've got around 9 CNC machines here, from a small 30 taper to a heavy duty 50 taper, HK 100, 3, 4 and 5 axis solutions here. So the doors are open, and we welcome people to come in and witness the strength of our product on our own machines here at Nikon.
Yeah, it's good. It's good to hear. Well, thank you, Gary. Thanks for joining us, and thanks for your support in this event. And we do look forward to working with you again shortly.
Okay, thank you, Ben.
Thank you.
So we're going to have a look at the 5-axis toolpath that we're using today. So we're using the barrel cutter, using the morph between 2 boundary curves strategy. So these are the faces that I've selected to machine, and then I'm going to morph between the first edge curve at the top and the second edge curve there at the bottom of those faces. Now the tool we're using is the barrel tool from Quick Grind. So again, it's been designed with a 70mm radius on the outer diameter there, so that we can achieve the best performance across these faces and get a nice clean finish as well. We've also got a 2.5mm radius on the bottom of the tool as well. So the step down is 1.5mm. I'm also varying the contact angle using the barrel section option, so that we're not cutting in the same place on that barrel cutter all the time. We vary the angle as we go down the walls. You can see here that we've applied the toolpath. It's done all 4 of those slots, and that's again because we have rotated that inside the operation 90 degrees 4 times. So if we give this a simulate, you'll be able to see the barrel tool working. We've also got the live cutting at the top left hand side there of the barrel cutter going around the component. And you can see that 1.5mm step down with that tool as it goes around those surfaces. So again, in comparison to using a ball nose, we've got a much greater step down, and we are achieving the same surface finish as we would do with a ball nose at 0.1, 0.2mm step over. So we're drastically reducing the cycle time for cutting these faces and still maintaining that same surface finish that we need. Now on this component as well, you can see there are some spot drilled holes around the outer diameter. For this we've used 5-axis drilling, so we simply click on the find holes. It will find all holes on that component, and then it will use the 5-axis engine to go around and machine all of those holes, or drill all of these holes. So again, you can choose from standard drilling, pecking, whatever type of drilling you need to do, and you can see picked up all those holes quite quickly. You can see it there on the machine running, and all it's doing is just using the 5-axis engine to rotate around to all those holes. Now lastly, what I want to show you on here was the engraving that we've done here as well. So standard engraving on the top, the Romy logo just in 3-axis, the SolidCAM and iMachining logo around the outer diameter, again just standard wrapped geometry. However, the engraving inside those blades is done with the 5-axis and tilting away from the blade. So you'll be able to see that there. I've got checking against the holder, so you can see it tilts around that blade, and we can see that on the machine here. It comes down and underneath that blade. So this is just doing the outside shape of the Nikon logo at the moment, and then we can see it go inside there, and it tips in and out to generate the lettering that goes inside that little shape we created.
Yeah, so as you saw in the presentation there, I showed the 5-axis drilling. It's 5-axis drilling at the moment, live on the machine, so you can see that going round the component. You saw how easy it was to pick up those holes. It's simply just a click of a button, find all holes. You can obviously use filters as well if you've got a component that's got different size holes in it and you only want to find one set of holes, so say all the 5mm holes. You can use the filters, click find holes, and just pick up all the 5mm holes as well. We've had a question as well in while we've been watching that. Oh, sorry, the machine just stopped. That's my fault, leaving it on op stop.
Proves it's live.
It proves it's live. It does prove it's live. So now it's going to do the chamfering as well. So it's going to chamfer around the top, and then we've got that 5-axis chamfering going around the blades as well. So like I said, there was a question coming as well. I was watching that. Is it possible to import angled heads in SolidCAM and use them, obviously?
Again, at the moment, yes, we can support all angle heads and all attachments on machines. It becomes a lot simpler in 2021, where you can actually put all your angled head, all your attachments within a library and literally just drag them in as you need them. So yeah, it becomes a lot easier in 2021, but it's not to say we can't do it now. We have full support for it at the moment anyway. But this will again give full simulation, everything else with it as well.
Yeah, and talking of 2021, obviously we're gonna do some more of these webinars based around 2021 next year, so we'll be talking about that a little bit later at the end. The chamfering now, we're in the 5-axis chamfering, so we're going round those blades. You can see it just take the edge off as we go around. This chamfer tool's running at 9,500 spindle speed and a feed rate of 500, just as we go around there, just breaking all the edge of that component off. So you can see the work holding on here as well. We're using a chuck today, so if you've watched any of the previous webinars, we've used a vise. This time we're using one of Shunk's chucks, and I caught up with Marcel a little earlier on in the week just to discuss the work holder we've got here and the other products that they offer as well. So I'll hand over to Marcel now.
Hi Marcel, welcome to SolidCAM Live. Thanks for joining us. Do you want to tell us a little bit more about Shunk and the obviously the products that you offer?
Well, thanks for having us yet one more time. Always a pleasure to join you guys on these events. Well, Shunk is a very comprehensive company in terms of applications for work holding and automation. So today on this event we are focusing on the work holding solution here. So we supply a new chuck for a 5-axis machine, which is a bit unusual, but the portfolio of the company, it's much broader than that. So starting from very simple work holding solutions, namely like mechanical vices, all the way to very specialist tombstones with or special jigs or hydraulic expansion mandrels going into your automation. So end effectors for end-of-arm robots like grippers, and the combination of both sides where you would go to the machine tending, which is I guess the buzzword at the time. We would have a complete solution for something like that as well. So it's hard to put everything in one quick presentation. There's about 11,000 products on our portfolio. And we also do a lot of special applications every year, so because that 11,000 is not quite enough.
Yeah, very good. Keep yourself very busy then.
It does indeed, yes.
Yeah, I mean, you touched on it there as well about the chuck that we're using. Do you want to explain a little bit more about the chuck that you supplied for today's event?
Yeah, so today we have a rotor. It's part of our portfolio. We have a wide family of chucks. Going from many applications to hydraulics and pneumatics, lightweight, heavy duty. The big brother of the rotor is the rotor flex, where you could expand that to meter 0.2 with the same core chuck. But what I like about this application today, it's very normal for us to do this, but it's very unusual, I guess, or not common to see people using a chuck for turning, milling, 5-axis application. You know, people's brains go directly into a lathe or turning when they think of a chuck, but it's a much more versatile work holding solution than people actually realize. And then I think you guys can say better than I can how much easier potentially this have made your life, having a cylindrical part, a round part that normally would be fairly challenging to centralize on a 5-axis.
Yeah, definitely. I mean, obviously using the vise, we don't need to try and centralise it each time we put the part in. It was much easier to hold the round billet rather than trying to prepare it first and then hold it in the vise. So yeah, it's been very good using the chuck, and the gripping power that it's got on there's been quite good as well. We've obviously using iMachining and some fast metal removal machine in there, so it's held up quite well on the machine as well. So I'm quite impressed with that. So yeah, I mean, are you guys, obviously we're in strange times at the moment, are you guys still operating as normal? Are you still open for business?
Yeah, it's been a challenging year, no question, but it has been also very good. We had some very large projects. We're operating as normal. We're very busy. We had some very nice applications coming from the aerospace, which is surprising at a time like this. The split of the company carries on very much the same. We're getting 60% of our revenue coming from automation, 40% from work holding, and we're trying to get busy with events like this, like we're doing today here with yourselves. And I would like to take the opportunity to say that if people want to have one-on-one sessions, digital sessions, so if they want to see a little bit more of whatever solution we have, really, like the chuck we have today, or tool holders, or automation, or machine tending, feel free to book, and we will have somebody available to go with them, be it one guy from their company or 1,000 people they want to show something that we might have a solution for.
Okay, yeah, that's a very good service that you offer there. Yeah, so I mean, yeah, thanks for your support with this event, and we look forward to working with you again on future events as we always do.
So do we. Thank you very much.
Thanks, Marcel.
Thanks, Marcel. As you can see, the product range that they have at Shunk is quite vast. And like I say, it may seem unusual to think about having a chuck on for a milling application, but in this case, absolutely perfect for what we're doing. The machine's now engraving the component, so we've got a 1.5mm ball nose on here, just 0.1 mil depth for cut. Just to mark the part. So we've got, at the moment, it's putting the Romy logo on there, and then we'll have all the other partner logos, including SolidCAM's as well, on there as we go around.
Including some up the actual flank of where the camera is, actually up the flank of the part as well. So it's not just on the faces you can get to easily. We've given it a little bit of a test as well.
Yeah, so we definitely give it a little bit of a test. So you'll see once the Romy logo finishes, you'll see it doing those logos up the flank of those blades. So it's just about to do that now. So I've used the 5-axis simultaneous operation in SolidCAM to do this. I showed a bit of it in my presentation. Now you're going to see it do it live. So you can see there, stay normal to the face until we get close to that blade, and then it will tip away from the blade and then come back up normal to that face again where it's clear. So this is where it's going to do the lettering now. You can see it just doing that check against that holder. There's about 1.5mm clearance on there, just as it goes underneath that blade. So I get some nice engraving on there as well. Now in terms of checking the component or checking the code as well, we have obviously used SolidCAM's machine simulation. And then as a secondary check, I've also used VeriCut before putting it on the machine. So just like to give it that second proof out, especially with it being 5-axis, and especially like you can see with that holder being so close to that blade. So VeriCut are one of our, or CG Tech as the company. VeriCut's the software that they use. They're obviously partners with us. We use them for these events. We use them for all sorts of other things as well. I caught up with Tim a little bit earlier in the week as well. We had a bit of a chat. So he's going to tell you a little bit more about VeriCut and some of the things that they offer as well.
Afternoon, Tim. Yeah, thanks for joining us to SolidCAM Live. Obviously, you're from CG Tech VeriCut. Do you want to tell us a little bit about VeriCut or CG Tech as a company, first of all?
Yeah, good afternoon, Ben. Again, thanks for inviting us along to your event. Yeah, so like you said, work for CG Tech, and we sell and support VeriCut within the UK and across a few European countries as well. And that's done from the UK office. There's 17 people in the UK. Most of them are technical support, big believers in, after sales support, if you like. That's where our focus tends to be, as well as product design. The product is VeriCut, and basically VeriCut is all about simulation, verification of your NC code, and also optimizing the NC code. So that, in a nutshell, is what we're all about, Ben.
Yeah, good. Well, I noticed you got a new release out around about September. I've been using that for this event. What's the sort of new enhancements in that that you've got?
Yeah, so that's, like you said, that got launched in September, so that's 9.11. So that's our latest release. There is a few patch releases after that, but yeah, it's all about making the user's productivity a lot more efficient, Ben, really. Enhancements to something called auto diff, which is the automatic difference between your design model and your cut stock. So that's something that the product's capable of doing, and that's to prevent any gouges or excess material once you've machined it. There's also enhancements for our force optimization package, or bolt on if you like, and that's again all about making it as efficient for the user to get the most out of the product as quick as possible. So there's a few enhancements in there. There's something called learn mode, so we can learn from the NC program to optimize the original code a lot slicker, and it means the user doesn't have to get as embroiled in the software. So and that's the push from our point of view, if you like. It's making the user more efficient.
Yeah, so a lot more user-friendly tools, really.
Absolutely, yeah.
So,
Yeah.
So I mean, obviously we're in strange times at the moment. Are you guys still operating as normal? You got plans for 2021 yet?
Yeah, well, I mean, it's, like you said, Ben, last 8 or 9 months has been very, very strange. But yeah, I mean, the majority of our lads work from their home offices anyway, certainly the support guys. So that's been business as usual. Again, sort of making the emphasis on supporting our customer base, encouraging new users to come on board, obviously, from a sales perspective. So yeah, it has been tough over the last few months, but we can see light at the end of the tunnel. And, there is some people that are struggling, but there's some people doing pretty well out there. And as far as 2021's concerned, we've got the sort of optimistic view, if you like, that come certainly back end of the first quarter, early second quarter, hopefully it'll be back to some form of normality. So we're making plans for 2021 along those lines, certainly from a marketing point of view, exhibitions, open houses, that sort of thing. So trying to get one step ahead, if you like, and get those plans in place.
Yeah, very good. Yeah, it's good to see. We all need to get back to some kind of normality at some point, don't we? So,
Definitely.
Yeah.
Definitely.
Well, yeah, thanks for your time, Tim, today, and yeah, thanks for all the support you give us during these events, and also not during these events as well. We obviously use you and use VeriCut quite a lot here, so thanks very much.
No problem whatsoever, Ben. Thanks for the invite.
Thanks.
See you soon.
See you soon.
Cheers. Bye.
Thanks for that, Tim. Yeah, it was great to catch up with you earlier on this week. We had a good chat about a few things. We've had a question as well. The machine stopped at the moment, so that's it finished. But we've had a question here. Is it possible to do pinch milling in SolidCAM, like for example on a twin turret machine?
Absolutely. Everything which we've shown pretty much up until now has been on the milling side of things, because obviously we're showing it on the 5-axis today, and it's a 5-axis based seminar today. We are just about to change it and show a little bit about some of the mill turn stuff in specifics, sliding head style machines on there. So this comes into play when we've got mill turn machines where we've got 2 turrets on there, and we want to be cutting and opposing tools on both on upper and lower turrets simultaneously. So absolutely no problem at all. You can can program them individually and then use the synchronization codes within inside SolidCAM on there, the weight codes on there to make them to work together. So you'll see a little bit of that on the presentation, which is just coming up. So this is based on a Citizen M32 machine on there, and it's time for me to do some more work. So,
yeah, over to you, Mark.
Thank you.
SolidCAM support for Swiss turn is both comprehensive and simple to use. In this overview, we will be demonstrating this on a Citizen M32 machine. This machine is a 3-channel machine with 5-axis capabilities, multiple machining patterns and superimposition. All of these features are fully supported in SolidCAM with full machine simulation. SolidCAM supports all tool holder types, including multi-station tool holders for both milling and turning tools. Tools can be moved to different stations and dynamically viewed to make sure the tools are set to the optimum position. Programming of operations is exactly the same as it would be for any mill turn machine in SolidCAM. Here we are selecting the area to turn directly from the model and the tool from the library. The toolpath is then calculated with full support of cycles on the machine. As with all operations, this can be viewed and simulated as the machine will cut it. Even adding more complex machining strategies such as cylindrical milling is kept simple. Select the area to machine direct from the model, the tool, and SolidCAM does the rest. Once the programming is complete, the channels can be optimized to get the best cycle time on the machine. Currently the part is programmed as a single part, but in reality we want to be working simultaneously on both spindles. This is done by selecting the operation to start machining on the second spindle. Now we can see the operations working together in all 3 channels. Based on this, SolidCAM will automatically choose appropriate machining patterns which can be reviewed and changed by the programmer, as in some cases alternate patterns are available. The programmer has full control over the positioning of the weight codes, and SolidCAM will assist this by dynamically checking and advising any issues. Now the complete program can be simulated as it would be cut on the machine with all axes working together. This highlights any potential collisions and will show any superimposition moves programmed, giving confidence the program is correct before being passed to the machine. This can significantly reduce machine downtime. Once this has been proven successfully, the G-code can be created in a single click, and here we see the result displayed in our SyncMaster software, clearly displaying weight marks and axis patterns. SolidCAM is available for all Swiss machines. For more information, please go to solidcam.com.
Okay, so that was just a quick insight to mill turn and to sliding heads on there. We support basically any configuration of machine from that point of view. So Ben's just taking the part out now and he'll show you on the camera, just to show, yep, that's what we've been working on, that's what we've cut today. You can see all the engraving around the flanks, all the 5-axis drilling, all the nice finish you're getting with the barrel tools on. So yeah, we can see everything which we've been working on. And so you can see on there, obviously, the machining time we've had on there. We've stopped the machine a couple of times while we've been talking and while we've been showing presentations, so that we can highlight certain areas which we think is worth watching for you. So the machining time was fairly straightforward, fairly quick on there. Now, just in summary on there, SolidCAM provides solutions for basically all types of machining, whether it's milling, turning, based from 2.5D right up to full 5-axis iMachining on the milling side, through also to turning from basic 2-axis to 3-axis with C-axis, right the way through to sliding heads. Everything works consistently the same way. So it is very, very straightforward product. We cover the full range of disciplines as I've just highlighted on there. So that's pretty much all we want to show today. So any questions on there, along the bottom of the screen there's been a banner going around with all our contact information. If you have any questions or want to get in touch with us, please do. You'll see all the information there. A big thank you to all our partners again, say to Quick Grind, to Romy, to Shunk, to Nikon and to CG Tech for their support in these seminars. We hope to have their support ongoing for future seminars. One of the prime reasons for having this technology centre is so that we can have customers, prospects, and run live seminars with people coming in and viewing it live. Obviously with restrictions at the moment we can't do that, and that's likely to be ongoing into the new year. So probably beginning of the new year this will be running a new set of seminars on there, but hopefully sooner rather than later we'll be able to invite people back through our doors and actually run them live and meet people face to face again. But obviously in the meantime we'll carry on doing this, getting the message out there, showing people what they want to see. So again, if people want to see something different on there, please use those contact details to get in touch. We'll try and accommodate as much as we possibly can. So thanks again to everybody for supporting us, both from our partners, as I say, and for you lot for watching on there. Thank you for that. We'll be back in the new year, so stay safe, have a good Christmas, have a good break, and hopefully we'll see everybody in the new year.
Yeah, thank you very much as well from me, and we'll see you in the new year.